Welcome, everyone. Ready to dive into a story that's really got space fans buzzing.
Oh, absolutely.
It's the Voyagers, launched back in '77
Wow, 77.
for a supposed quick 5-year trip just to peek at the outer planets. But guess what? Almost 50 years later, they're still going.
It's incredible, isn't it? They're really pushing the boundaries.
But here's the thing. To keep these pioneers going, NASA just made a tough call. They're powering some instruments down.
Yeah, bittersweet decision for sure.
So why do that? That's what we're going to unpack today.
Right. It really shows how clever the teams are, how resourceful. See, the Voyagers, they run on these things called RTGs.
RTGs, okay, catchy. But like, how do they actually work? And what's the problem now?
Well, basically, they use the heat from decaying plutonium to make electricity.
Ah, plutonium.
Perfect for a long mission.
Mm-hmm.
But it means the power's always dropping. Like, think of a phone battery that slowly drains, even when you're not using it.
Okay, makes sense. So each year,
Each year, the Voyagers lose about 4 watts.
4 watts, so it's a slow decline then.
Very slow, but it adds up over time. Every bit of energy counts when you're billions of kilometers away from the sun.
Right, no charging stations out there. But still, to actually switch things off on these historic probes must have been a hard choice.
Oh, for sure. Every instrument's been crucial to their discoveries, like take Voyager 1's cosmic ray system. Help pinpoint the exact moment it left our solar system's bubble, the heliosphere, back in 2012.
Whoa, crossing the heliosphere, like
Yep.
stepping out of the sun's protection into the wild west of interstellar space. What was that like based on the data? I mean, what did they see?
Oh, it's monumental. Voyager 1, officially in interstellar space, the region between stars,
Mm-hmm.
filled with gas, dust, cosmic rays, and the data, it showed a huge shift, like the type of particles hitting the probe, their intensity.
Yeah.
Everything changed.
So a whole new world out there.
Absolutely.
Yeah.
And soon, Voyager 2's low-energy charged particle instrument,
Yeah.
vital for studying solar wind, that's going offline too.
That data must have been amazing. But it seems counterintuitive, right? Just as they're entering this uncharted territory, they have to start shutting down. So what's the plan now? What's still working, still gathering data in this new frontier?
Well, each Voyager still has 3 key instruments running: the magnetometer, the plasma wave subsystem, and the ultraviolet spectrometer.
Okay, break those down for me. What are they actually like listening to or measuring out there in the vastness of space?
Sure, the magnetometer is like a super sensitive compass, mapping the magnetic fields out there.
Oh, wow.
Yeah, and those fields, they're totally different from what we see in our solar system. Gives us clues about the forces at play in the galaxy.
So it's like getting a feel for the magnetic landscape of this uncharted territory.
Exactly. And then you got the plasma wave subsystem. Basically, it's listening to the sound of space,
Hmm.
picking up vibrations, waves in that alien environment.
The sound of space. Trying to imagine what that's like. Probably not as melodic as those golden records they're carrying, right?
Probably not.
Yeah.
But it gives us a sense of the activity out there, the dynamics of interstellar space. It's really quite fascinating.
I bet. And the last one, the ultraviolet spectrometer.
Ah, yes. That one analyzes ultraviolet light. Stuff we can't see, coming from stars, other objects. Helps us figure out what they're made of and how they interact with that interstellar stuff.
So even though we can't see it, that ultraviolet light, it's carrying secrets, telling us about what the universe is made of.
You got it. And picking these 3 instruments wasn't random. They give the most unique data about the interstellar medium, but use the least power.
Ah, clever. It's all about stretching that power as long as possible.
Exactly. Strategic choices to keep the mission going.
Like a cosmic balancing act.
You could say that.
Prioritizing the best data while making the most of what they've got. So what other tricks do they have? It's not like they can plug into a charging station out there, right?
Huh? No charging stations in interstellar space. Nope, no pit stops for these guys. It's pretty amazing though, right? That they're still going. I mean, think about it. They were designed with 1970s tech.
Right. Makes you appreciate the engineers thinking ahead like that. But what are these power-saving tricks? What's it like to put a probe in low power mode, way out there?
It's really interesting. They've had to get creative. Beyond just turning things off, it's about power management. Like, imagine you're on a road trip, limited gas.
Right.
You start making choices, right?
Yeah.
How fast you drive, which roads to take, what you can carry.
So it's like hypermiling, but across the galaxy?
Kind of, yeah.
Yeah.
They're super careful about what data gets sent back to Earth. It's like deciding which photos to upload when your data's low. Only the most important stuff, scientifically, gets priority.
I get it. Don't want to waste energy on stuff that don't tell us anything new, but that must be a lot of pressure on the scientists to pick the right data.
It is. It's a constant back and forth between wanting to know everything and the reality of limited resources. But even with those constraints, the data they are sending, especially from those three instruments, it's valuable. We're learning so much about the interstellar medium, stuff we could only guess at before the Voyagers went out there.
We talked a bit about what each one measures, but big picture, what questions are they helping answer about that interstellar medium?
Well, one of the biggest ones is how the sun's influence interacts with the interstellar medium. Our solar system is surrounded by this bubble called the heliosphere, made by the solar wind.
Ah, the solar wind, that constant stream of particles from the sun.
Yep. So it's like a giant shield protecting our solar system.
Exactly. It deflects a lot of cosmic rays, those super fast particles coming in from interstellar space.
Right, the ones the Voyagers are measuring now, that they're outside the heliosphere. Yes. And what they found when they crossed that boundary was really interesting. The heliosphere, it's not a perfect bubble like we thought. It's more like, imagine a boat pushing through water. Makes a wave in front and a wake behind.
Oh, okay. I see. So the sun's the boat, interstellar space is the water.
Right. The heliosphere has this bow shock where the solar wind hits the interstellar medium and then this turbulent area trailing behind like a wake. And the Voyagers, they flew through these regions, giving us our first close-up look at how this all works.
Wow, so they're not just exploring out there, they're helping us understand how our own solar system fits into the galaxy, puts things in perspective.
It does. And it shows why these missions are so important. We think about exploring as going outward, right, to far-off stars. But the Voyagers, they've shown us there's so much to learn right here in our cosmic neighborhood about what shapes our solar system.
It's mind-blowing that we can still talk to them after all this time. At these distances, how is it even possible? It's not like picking up the phone, right?
It's incredible technology, really. It's the deep space network, these huge radio antennas around the world.
Giant ears listening for these tiny whispers from across space.
That's a great way to put it, and it's not easy. The signals, they're super faint. And it takes over 22 hours for a message to get to Voyager 1, just one way.
So every bit of data is precious, especially with their limited power.
Absolutely. Each transmission is carefully planned, making the most of those tiny windows of contact. And as they get farther away, the signals will get weaker, communication even harder.
It's amazing they're still pushing the boundaries, even as their power is running low. The exploration and the communication itself.
It shows how clever the engineers and scientists are, constantly finding ways to keep these missions going.
Before we move on, I'd love to know more about the heliosphere. You mentioned it's like a shield. What's it shielding us from? And what did the Voyagers find out when they crossed that boundary?
It's a fascinating area, this heliosphere. It's basically a bubble carved out of interstellar space by the solar wind, that constant stream of particles coming from the sun.
So the sun's like blowing this bubble around itself.
Yeah, a really energetic bubble. And it acts as this shield, deflecting a lot of those cosmic rays that are always hitting our solar system, coming in from interstellar space,
Cosmic rays. Those are those super fast, high-energy particles, right? The ones the Voyagers are measuring now out there beyond the heliosphere.
Exactly. And what they found out, crossing that boundary, was pretty amazing. The heliosphere. It's not this smooth, even bubble like we used to think.
Yeah.
It's more like, picture a boat moving through water. Makes a wave at the front and leaves a trail behind it.
Oh, okay, I can see that. So the sun's like the boat and interstellar space is the water.
That's it. The heliosphere has got this bow shock where the solar wind crashes into the interstellar medium and then this turbulent area behind it, like a wake. And the Voyagers, they actually flew through these areas, giving us our first real look at how this all happens,
Wow, so they're not just exploring way out there, they're helping us understand how our own solar system fits in with the rest of the galaxy. Really puts things in perspective.
It does, and it shows why these missions are so important. We tend to think about exploring as going outward, right, to the stars, but the Voyagers have shown us there's so much to learn right here in our own cosmic neighborhood about the very things that shape our solar system.
It's incredible, the whole idea that we can still talk to them after all this time at these distances. How does that even work? It's not like picking up the phone.
It really is amazing technology. We use the deep space network, these huge radio antennas all over the planet.
Like giant ears listening for these faint whispers from across all that space.
That's a great way to put it. And it's not easy. The signals are incredibly faint, and it takes over 22 hours for a message to reach Voyager 1. And that's just one way.
Wow, 22 hours, so every bit of data is precious. especially with their limited power supply.
Absolutely. Each transmission is carefully planned, to make the most of every opportunity. And as they travel further, the signals will get even fainter, making communication even more challenging.
It really is remarkable. They're still pushing the boundaries, even as their power's running low, both with the exploration itself and how we even stay in touch.
It's a testament to the ingenuity of the engineers and scientists, constantly finding new ways to keep these missions alive.
It really is. So we've talked about powering down some instruments to save energy, and that makes sense. But there's still so much we can learn from the Voyagers.
Absolutely. Every little bit of data helps us paint a clearer picture of what's out there, like those golden records they carry.
Oh, yeah, those
Yeah.
golden records. It's like sending a message in a bottle out into the vast cosmic ocean, hoping someone, someday, might find it. Gives me chills just thinking about it.
It really captures the imagination, doesn't it? This idea of reaching out across time and space. Who knows, maybe millions of years from now, someone will stumble upon those records, and the story of the Voyagers will continue in ways we can't even imagine.
I love that thought. It makes the universe feel a little less lonely somehow. But it also makes me wonder, why do we do this? Why explore space? Especially when we have so many problems here on Earth.
That's a deep question, and I think there are many answers. For some, it's about pushing the boundaries of what we know, figuring out where we fit in this huge universe. For others, it's about the spin-offs, the technology that comes from these missions that helps us here at home.
Oh, right. Like all those things we use every day.
Yeah.
That came from space exploration,
Mm,
medical imaging, GPS.
exactly. But beyond the practical stuff, I think there's something more fundamental going on. Exploration is part of being human. It's that curiosity, that urge to see what's over the horizon, to discover the unknown. It's what drove our ancestors to cross oceans, explore new continents, and now to reach for the stars.
It's like we're hardwired to explore, always pushing the limits of what we know and where we can go.
Exactly. And space exploration especially, it has this power to inspire, to fire up our imaginations, to remind us that there's so much more out there than our everyday lives.
It's about expanding our horizons, literally and figuratively. And the Voyagers, they really embody that spirit. They've shown us what's possible when we combine human ingenuity, that desire to learn, and the courage to venture into the unknown.
They really are pioneers, showing the way for future missions.
Mhm.
And even though their time is limited, their legacy, it lasts for generations.
You've summed it up beautifully. It's been a journey through space and time, a celebration of what humans can achieve, and a reminder that even when things seem vast and uncertain, there's always more to learn, always more to discover.
And who knows what wonders are waiting out there. Maybe someday future missions will follow in the Voyager's path, carrying our curiosity, our dreams, even further.
Until then, we'll keep looking to the Voyagers. They've shown us what's possible, that even the smallest probes can make the most incredible journeys.
Keep looking up, keep asking questions. You never know what you might find.
And on that note, we'll leave you with this thought. If you could send a message to the stars, what would it be? Until next time, keep exploring.